Hi, 8th grade. Welcome to lesson 1-6. Today we are going to use properties of integer exponents. So by the end of the lesson, you will be able to say, I can use the properties of exponents to write equivalent expressions. Today we're only going to do the first half of the lesson because there are 4 properties. And I only want to do 2 at a time so we can really focus on each of the properties. So let's try this, solve, and discuss it. One band's streaming video concert to benefit a global charity cost $1 to view. The first day, the concert got 2,187 views. The second day, it got about 3 times as many. On the third time, it got 3 times as many as the second day. If the trend continues, how much money will the band raise on day 7? Okay, so if the first day, they got 2,187 views, and each view cost $1. How much money did they make on the first day? They made $2,187. On the second day, it said their views tripled. So what do we have to do to 2,187 to figure out how many views there were? Multiply by 3. If you have your calculator, great, do that for me. If not, go back and get it. It should be 6,561 views, which gives us how much money? 6,561. Then on this, it says, if the trend continues, how much money will the band raise on day 7? So I want you to do, we've got 1, 2. So now you got to find out day 3, day 3, day 4, day 5, day 6, day 7. Each time you're tripling. So you can pause the video, fill those out, and I will ask for some participants. If you're just watching at home, feel free to play through. All right, so hopefully you got these answers. 6,561 times 3 gives us 19,683. That times 3, 59,049. That times 3, 177,147. Times 3. I want to put a separator in here so you don't think it's the same number. 531,441. And last but not least, that times 3 gives us 1,594,323. So by the 7th day, this band has raised over $1 million for charity. Use prime factorization to write an expression equivalent to the amount of money raised by the band on the last day of the week. So we're starting with 2,187. From there, to get to the next number, we multiply by 3. To the next number, we multiply by 3. So that's 1, 2, 3, 4, 5, 6, 7. So to write this nicer, talking about exponents, we have 2,187 times 3 raised to what power? Well, there's 1, 2, 3, 4, 5, 6 3s. So that means it's going to be 3 to the 6th power. Example 1. The weight of a newborn male caribou is shown on the right. On average, the adult male caribou weighs up to 2 to the 6th times more than the newborn. So we're looking at 2 to the 6th, and we're also looking at the word times. more than the newborn. How can you determine the average weight of an adult male caribou? So, first we have the weight of the baby. Then we have the weight that is times the baby to get to the adult. 2 to the third means we're doing 2 3 times. So we've got 1, 2, 3. 2 to the sixth means we're doing it 6 times. So if we join the expressions together, we're multiplying these two. We end up getting 2 to the 9th power because there are 9 2's. This is the long drawn out way. I'm totally okay with you using it. But here's the product of powers property. This is one of your vocab words. The product of powers property states that when multiplying two powers with the same base, add the exponents. So talking about exponents in general, the big number at the bottom is called the base, and the small number up top, is called the exponent. So here, both of our bases were 2. And we're multiplying. So it says when we multiply, all we have to do is add the exponents. So that's why we kept the base. 3 plus 6 equals 9. So maybe if we had something like 3 squared times 3 to the 4th power, we keep the base. The base is the big number on the bottom. That stays the same, so it's still 3. And what do we have to do with the exponents? Add them. 2 plus 4. So this gives us 3 raised to the 6th power. So when multiplying with the same base, so why don't you highlight this or underline this, multiply in same base, I want you to write add exponents. Try it. The local zoo welcomed a newborn African elephant that weighed 3 to the 4th kilograms. It is expected that in adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as its birth weight. So we have the starting weight of 3 to the 4th. And then we know it's going to be 3 to the 4th times as much. So that's telling me to multiply by 3 to the 4th. So we're multiplying, we have the same base. So we keep the base the same. What do we do with the exponents? Multiplying with the same base, what do we do with the exponents? Add. So that's 4 plus 4, which gives us 3 raised to what power? 8. Explain why the product of power property makes mathematical sense. Well, if we did it out long way, 3 to the 4th times 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3. So that would be there. Times, again, another 3 to the 4th. 3 times 3 times 3 times 3. So how many total 3's do we have here? Count them. 1, 2, 3, 4, 5, 6, 7, 8. So it should be 3 to the 8th power. Example number 2. Multiply exponential expressions with different base. So find the volume of the cubic inches of a cube with an edge length of 2 feet. So if the volume is equal to 2 cubed, and the other one is 12 cubed, we want to multiply them. 2 cubed times 12 cubed. Now this one's different because the bases are different base, but the exponents are the same. So different base, exponents are the same. Here, we've got 2 times 2 times 2 and 12 times 12 times 12. Well, if you think about it, 1 2 gets brought down and a 12 gets brought over. 1 2 gets brought down and 12 gets brought down. And 2 and 12. So we're just rearranging it. So then we end up getting the expression 2 times 12 3 times, which is 24. So if they have the same exponent, different base, multiply the bases and keep the exponent. Again, here's another vocab word. Be very careful because it sounds similar to the other one. We have a product of powers and we have the power of products. The power of products is when you're multiplying two exponential expressions with the same exponent in different bases. You multiply the bases and keep the exponent the same. So we're going to stop learning here, but we want to try it. So turn to the next page and look at the key concept just at the top. Use these properties when simplifying expressions with exponents. So here, notice how we have the same base, so the base stays the same. We have different exponents, so we need to add them since you're multiplying. Okay? Here, we have the same exponent, so the exponent stays the same. And then we just multiply the bases together. So as a general rule of thumb, whatever's the same stays the same. So the same stays same. And then you need to figure out if it's an exponent, you need to add them. If it's the base, you need to multiply. So what I want you to do now on this page is to do numbers 5 and 7. 5 and 7 on this page. Once you finish it, show one of us and we will check it and give you your exit quiz and your homework. Enjoy.